Cosmic curiosity, a shadow over solar power. The sun, a blazing ball of fire, powers our planet, providing the energy that sustains life and drives our technology. We harness its energy in many ways. One of the most efficient methods is through solar panels, which are becoming increasingly common. These panels convert sunlight into electricity, a process that is both clean and renewable. But what happens when the sun briefly disappears behind the moon during a solar eclipse? What happens to our solar panels during this celestial event? It's a question that sparks curiosity and scientific inquiry. We look up at the sky both amazed and a little bit nervous, wondering about the impact on our solar energy systems. As the moon passes between the sun and the earth, it casts a shadow. This shadow falls upon us, creating a temporary darkness. Will our solar panels still work under these conditions? The answer, like the universe itself, is fascinating and complex. Yes, solar panels do still work during a solar eclipse, but not as efficiently. Their energy output drops significantly because the moon blocks the sunlight that powers them. This is because the moon obstructs the sunlight, reducing the amount of energy that reaches the panels. To understand this better, let's explore how solar panels work and how they respond to changes in sunlight. Sunlight to electricity, the magic of solar panels. Solar panels are marvels of modern science. They are made up of many solar cells, usually silicon. These cells are designed to capture sunlight, but how do they turn light into electricity? It's all about the photons. Photons are tiny particles of light. When these photons hit a solar cell, they knock electrons loose. These electrons then flow through an electrical circuit, creating electricity. The more sunlight hits the solar panel, the more photons are available. This means more electrons are set free and more electricity is generated. But during a solar eclipse, the amount of sunlight reaching the Earth decreases, and so does the electricity generated by solar panels. Eclipses effect, a temporary dip in the light. During a solar eclipse, the moon acts like a giant shade. It temporarily blocks sunlight from reaching the Earth. The amount of sunlight blocked depends on the type of eclipse. A total solar eclipse blocks all direct sunlight. This creates an eerie twilight on Earth. A partial solar eclipse blocks only a portion of the sun. This results in a less dramatic dimming of the sunlight. As the moon covers the sun, solar panels experience a decrease in sunlight. This directly affects their electricity production. The output drops proportionally to the amount of sunlight blocked. The effect is temporary, lasting only as long as the eclipse itself. Section 4. Real-world impact California's solar eclipse experience. The impact of a solar eclipse on solar power is not just theoretical, it's a tangible event that has real consequences for energy production. It's a real-world phenomenon that has been observed and studied extensively by scientists and researchers. One notable example is California, a state that heavily relies on solar energy for a significant portion of its power needs. During the August 2017 solar eclipse, California experienced a significant dip in solar power generation, which was closely monitored. As the moon passed in front of the sun, solar farms across the state saw their output decrease dramatically. The impact was noticeable, though not catastrophic, thanks to careful planning and preparation. California's experience highlights the importance of planning for eclipses and other natural events that can affect solar power. While the impact on the power grid was manageable, it underscored the need for reliable backup energy sources to ensure stability. It also spurred the solar industry to develop innovative strategies for mitigating the effects of future eclipses, ensuring a more resilient energy grid. Section 5. Planning for the cosmos, the solar industry's eclipse strategy. The solar industry is constantly innovating, always pushing the boundaries of technology and efficiency. It's no surprise then that it has developed ways to prepare for solar eclipses, ensuring that energy production remains uninterrupted. These strategies ensure a stable power supply even when the sun takes a temporary break, maintaining the balance of the grid. One key strategy is to diversify energy sources, integrating various forms of renewable energy. By combining solar power with other renewables like wind and hydro, grids become more resilient to fluctuations, ensuring a continuous energy flow. Energy storage, like batteries, also plays a crucial role in this strategy. They can store excess energy generated during sunny periods and release it during eclipses, providing a reliable backup. Another strategy is accurate forecasting, which is essential for planning. Scientists can predict the timing and path of eclipses with great precision, allowing for better preparation. This allows utility companies to anticipate drops in solar power and adjust their energy mix accordingly, ensuring that the grid remains stable and efficient throughout the event. Section 6. The final word: eclipses and the future of solar energy. Solar eclipses offer a glimpse into the dynamic relationship between the cosmos and our energy systems. While they temporarily reduce solar power output, they do not diminish the importance of solar energy. The solar industry is well equipped to handle these celestial events. Through innovation and planning, we can ensure a reliable and sustainable energy future. So the next time you witness the awe-inspiring spectacle of a solar eclipse, remember this: even in the face of cosmic shadows, the future of solar energy remains bright.